Let's learn more about defining functions. The code below converts a temperature from Fahrenheit to Celsius. This code has some issues, however. First, the calculation is called multiple times in the code, which makes it much more likely for a mistake to occur when typing it. Second, if a mistake does occur, it will be harder to track down in the offending lines. Third, anyone not familiar with the code might wonder what the code is doing. A function will help us with all of these problems. We begin with the skeleton of a function. In BlockBy, the function block generates this function skeleton, ready for editing. If you cannot name a function, then you probably don't know what it should do. We know that this function will convert a temperature, so let's call it convertTemperature. This name is short and has a verb. Notice how I used underscores to represent spaces, because function names follow the same rules that variables do. You need to identify what is the same and what is different about each call. Extract out the code that is the same. Here, we've extracted out the calculation. We could have extracted out the print too, but remember that printing and returning are different. Usually, functions never need to print anything. Notice the blank in the code that we extracted. Since the value we converted was different each time, we need to parameterize it by giving these concrete values a more general name. In this case, each time it was a temperature in Fahrenheit, so we'll call this A_Fahrenheit. We put this new parameter in the function's header and then use it in the body. The code we've created is meant to go inside the body of the function, but we have nothing to connect it to just yet. Recall that this function should return the temperature in Celsius. Therefore, we need a return block. This gives us the open connection that we need to incorporate the formula we extracted earlier. Finally, we can now call our function in the code. Notice how we connect the original values as arguments for our function call. So, what happens when you actually call a function? Let's see it in action. Notice how the execution jumps backwards when we call a function and then returns later. Here, we turned existing code into a function definition and then called the function. Another common approach is to do the opposite. Write the function call and then use that to write the function definition. Use whichever order is more comfortable for you when solving each problem. When writing out a solution, you can use a powerful tool called functional decomposition. The idea is to break a complex problem into easier parts. Consider the task of going to the store. You could break this long algorithm into 3 shorter subtasks and focus on solving each in turn. First, you get in the car. Then, you drive the car to the store. Then, you exit the car into the store. We have now learned a few key words: def, return, and pass. In previous lessons, we learned a few other keywords: and, or, not, and in. Python has a small set of keywords, and you will eventually learn most of them. An important detail to remember is that we cannot name variables or functions using keywords, because Python will get confused by what we are trying to say.